Welcome to Sleepy Science Channel. Like, subscribe, and write where you are watching from. Imagine for a moment that time is not something you measure with a clock, but something that stretches endlessly in all directions. A slow and quiet ocean where seconds become small waves and millions of years become almost invisible ripples. When we speak about millions of years in the universe, we're not speaking about something ancient in the way human history feels ancient. We are speaking about a very small fraction of a much larger story. The universe itself is about 8 billion years old, and a million years compared to that is like a single breath compared to an entire lifetime. So when we ask what space was like millions of years ago, we are not traveling to a completely different universe, but rather to a slightly earlier version of the same vast and slowly evolving system. One that was already filled with stars, galaxies, and silent motion. Everything already existed in complex forms, but it was all just a little younger, a little closer together, and slightly different in arrangement. In that earlier time, the universe already had structure. Galaxies had formed long before. Stars were already living and dying, and enormous clouds of gas were drifting slowly through space. But the positions of everything were slightly different. Galaxies were a little closer to each other. Stars were in different places, and the light traveling through space had not yet reached where we are now. Because light itself needs time to move, and this is one of the most important ideas to understand. When we look into space, we are always looking into the past. Even the light from our nearest star takes years to arrive, and the light from distant galaxies takes millions or even billions of years. So in a way, when we ask what space was like millions of years ago, we are already seeing it. Every time we look up at the night sky, we are observing a universe that is not exactly present, but gently delayed, a quiet echo of what once was. That means space from millions of years ago is not lost. It is still reaching us, slowly and patiently, carried by light across unimaginable distances. The universe we see is a mixture of times. Some parts are closer to now. Some parts are far in the past. And together they form a calm and continuous story that never truly stops. As we continue to move gently through this vast timeline, the universe from millions of years ago reveals itself not as a static picture, but as a slow and continuous motion, where galaxies drift through space like silent islands in a dark ocean, each one carrying billions of stars, and each one slowly changing its position over immense stretches of time. These movements are not fast in the way we understand motion. They are incredibly slow, almost impossible to notice within a human lifetime. Yet over millions of years, they reshape the structure of the universe in subtle but powerful ways. Galaxies are constantly pulled by gravity, influenced by the invisible presence of dark matter, and guided along enormous cosmic structures that stretch across space like a hidden web. Millions of years ago, galaxies were slightly closer to each other than they are today, because the universe has been expanding over time, slowly increasing the distances between these massive systems. This means that if you could travel back millions of years and observe the sky from the same point in space, the positions of distant galaxies would look slightly different, closer, and more connected, forming patterns that have since stretched and shifted. Some galaxies were already interacting, their shapes distorted by gravitational forces, their stars pulled into long streams that extended far into the darkness. These interactions were not violent in a sudden way, but rather graceful and slow, taking hundreds of millions of years to fully unfold. Within these galaxies, stars were being born in large clouds of gas and dust, regions where gravity slowly gathered material together until new stars ignited, filling their surroundings with light. Millions of years ago, this process was still ongoing everywhere, and in some parts of the universe, it was even more active than it is today. Galaxies were brighter in certain regions, filled with young stars that burned intensely, while other areas were already aging, populated by older stars that glowed more softly. This balance between birth and aging gave each galaxy a unique appearance, a mixture of bright clusters and dim, ancient light. If we focus on our own galaxy, the Milky Way, it too was in motion, rotating slowly, its spiral arms shifting over time. Stars moving along paths that take millions of years to complete a single orbit around the center. Millions of years ago, the position of our solar system within this galaxy was slightly different, not dramatically so, but enough that the nearby stars in the sky would not appear exactly as they do now. Constellations, which feel fixed and permanent to us, are actually temporary patterns, slowly changing as stars move through space. If you could observe the night sky from millions of years ago, the familiar shapes would be altered, stretched, or even unrecognizable, forming new patterns that no human has ever seen. This gentle movement extends even further, beyond individual galaxies, into clusters and superclusters, where groups of galaxies are bound together by gravity, drifting slowly as a collective system. Millions of years ago, these clusters were also slightly more compact, their galaxies interacting more closely, influencing each other through gravity in ways that shaped their evolution. Over time, these interactions can lead to mergers, where two galaxies slowly come together, their stars mixing, their structures changing, eventually forming a new and larger galaxy. This process is happening even now, and it has been happening for billions of years, quietly reshaping the universe without any sudden interruption. So when we imagine space millions of years ago, we are not imagining a different place, but a slightly earlier moment in a continuous flow where everything is in motion, everything is connected, and everything is changing at a pace so slow that it feels almost still. The universe at that time was calm, yet full of silent movement, a place where galaxies drifted, stars were born and faded, and light traveled patiently across the darkness, carrying with it the story of a universe that is always becoming something new, even when it appears completely still. As we continue to move deeper into this quiet and endless timeline, the universe from millions of years ago reveals another layer of its nature, one that exists inside the galaxies themselves, where stars are constantly being born, living their lives, and slowly fading away, creating a cycle that never truly stops. This cycle is one of the most important processes in the universe, because stars are not only sources of light, they are also the creators of the elements that form planets, atmospheres, and even the building blocks of life. Millions of years ago, this cycle was already in motion everywhere, quietly shaping the structure and content of the cosmos. In vast regions filled with cold gas and fine cosmic dust, gravity slowly begins to pull material together, forming dense areas where pressure and temperature gradually rise, and after a long period of silent accumulation, a new star is born. This process takes millions of years, and it happens inside enormous clouds known as nebulae, which drift through galaxies like soft and glowing formations. Millions of years ago, many of these regions were more active, especially in galaxies that were still rich in gas, meaning that star formation was happening more frequently in certain parts of the universe. These newborn stars often appear in groups, forming clusters that shine brightly together, illuminating their surroundings with intense light. But not all stars live the same kind of life. Some are small and stable, slowly burning their fuel over billions of years, while others are massive and short-lived, burning intensely and ending their lives in dramatic events. Millions of years ago, many of the largest stars that existed at that time have already completed their lives, because massive stars do not last long. They consume their energy quickly and reach their end in a relatively short cosmic time. When such a star reaches the end of its life, it can explode in a powerful event known as a supernova, releasing an enormous amount of energy and scattering heavy elements into the surrounding space. These explosions are not only moments of destruction, they are also moments of creation, because the materials released by supernovae become part of future stars and planets. Millions of years ago, the universe experienced many of these events, more frequently in regions where star formation was high, and each explosion contributed to the gradual enrichment of the cosmos, turning simple elements into more complex ones. Over time, this process changed the composition of galaxies, making it possible for rocky planets and more complex structures to form. In contrast, smaller stars end their lives more gently, expanding into red giants and eventually shedding their outer layers, leaving behind a dense core known as a white dwarf. This quieter ending also contributes material back into space, continuing the slow recycling process that defines the universe. Millions of years ago, countless stars were at different stages of this cycle, some just beginning, some in the middle of their lives, and others reaching their final moments, all existing together in a vast and balanced system. If you could observe a region of space from millions of years ago, you would see a mixture of bright young stars, glowing clusters, aging stars with softer light, and the faint remnants of stars that have already ended their lives. The universe would appear both active and calm at the same time, filled with light, but also with quiet transitions that happen over incredibly long periods. Nothing would feel rushed. Everything would unfold slowly, guided by the steady influence of gravity and energy. This continuous cycle of birth and death means that the universe is never truly the same from one moment to the next, even if the changes are too slow to notice directly. Millions of years ago, the stars that filled the sky were not exactly the same as those we see now. Some have disappeared, some have changed, and new ones have taken their place. Yet the overall pattern remains, a calm and repeating rhythm that continues without interruption, creating a sense of quiet continuity across time. In this way, the universe from millions of years ago was already alive with transformation, not in a sudden or chaotic sense, but in a gentle and ongoing process where stars quietly shaped their surroundings, released their energy, and contributed to the endless story of the cosmos, a story that continues to unfold slowly and endlessly across the dark and peaceful expanse of space. As we continue drifting through this calm and slowly changing universe, another hidden force begins to reveal itself, something that cannot be seen directly yet shapes entire galaxies, black holes, regions where gravity becomes so strong that not even light can escape. And millions of years ago, these mysterious objects were already present, quietly growing and influencing the space around them. Black holes do not glow like stars. They do not shine on their own, yet their presence can be felt through the motion of nearby matter, through the way gas swirls and accelerates, and through the paths of stars that move under their invisible pull. In the centers of most galaxies, including our own, there exists a supermassive black hole, an object millions or even billions of times more massive than our sun. And millions of years ago, these central black holes were often more active than they appear today. When gas and dust fall toward a black hole, they do not disappear instantly. Instead, they form a rotating disk, heating up as they spiral inward, releasing energy in the form of light and radiation. During periods of intense activity, these regions can become extremely bright, outshining entire galaxies, creating what we call active galactic nuclei. Millions of years ago, in certain parts of the universe, these active centers were more common because galaxies contained more freely moving gas that could feed their central black holes. This made some galaxies appear brighter and more energetic than they are now, with streams of material being pulled inward, creating long jets of energy that extend far beyond the galaxy itself. These jets, though invisible to the human eye, carry enormous power, shaping the surrounding space, heating gas, and influencing the formation of new stars. But not all black holes are supermassive. Many are formed from the remains of massive stars that have ended their lives in supernova explosions, collapsing into incredibly dense points. Millions of years ago, these smaller black holes were scattered throughout galaxies, quietly moving through space, sometimes alone, sometimes as part of binary systems, where they orbit other stars or even other black holes. In some cases, two black holes slowly move closer together, spiraling inward over millions of years until they finally merge, releasing a powerful burst of gravitational waves that ripple through the fabric of space itself. These events are silent in the traditional sense. There is no sound traveling through space. Yet they are not truly quiet, because the energy involved is immense, and the effects spread across vast distances. Millions of years ago, such mergers were already happening, though rarely from a human perspective. They are part of the ongoing evolution of the universe, subtle yet powerful changes that reshape the invisible structure of space. If you could observe a galaxy from millions of years ago with the right instruments, you might detect the presence of its central black hole, not by seeing it directly, but by noticing how stars move faster near the center, or how gas forms a bright rotating disk before disappearing. You might see sudden flares of energy as matter falls inward, or long jets extending into the darkness, marking the presence of something hidden yet dominant. Despite their intense nature, black holes do not actively seek out matter, they simply exist, and their gravity influences whatever comes close enough. Millions of years ago, just like today, most of space around them remained empty, and their effects were limited to their surroundings. Yet over long periods of time, they played a key role in shaping galaxies, controlling the flow of gas, and even regulating how many new stars could form. This means that the universe from millions of years ago was not only shaped by visible objects like stars and galaxies, but also by these invisible centers of gravity, quietly guiding the structure of everything around them. Their presence adds another layer to the calm complexity of the cosmos. A reminder that even in the deepest silence of space, there are forces at work, steady and patient, shaping the universe in ways that are not always immediately visible, yet always present. As we continue to drift deeper into this calm and ancient universe, the space between stars begins to feel less empty than it first appears. Because millions of years ago, just like now, vast regions of galaxies were filled with enormous clouds of gas and fine cosmic dust, spreading quietly across space, forming soft and almost invisible structures that only reveal themselves under certain light. These clouds are not solid. They are extremely thin compared to anything on Earth, yet they stretch across distances so large that they become the birthplaces of stars and planetary systems, creating a gentle and continuous transformation within galaxies. These clouds are mainly composed of hydrogen, the simplest and most abundant element in the universe, along with helium and traces of heavier elements that were created in earlier generations of stars. Millions of years ago, these clouds were often more abundant in certain regions, especially in younger parts of galaxies where star formation was still active and ongoing. In these areas, gravity slowly pulls the gas together, creating denser pockets that begin a long process of collapse, one that can take millions of years before a single star is born. The presence of dust within these clouds adds another layer of quiet complexity. Tiny particles made of heavier elements, scattered throughout the gas, absorbing and scattering light, giving nebulae their soft and sometimes colorful appearance when observed from a distance. Millions of years ago, these dust particles were slightly less common in the very early universe. But over time, as more stars lived and died, the amount of dust increased, enriching the clouds and making them more effective at forming new stars and planets. In some regions, these clouds appeared dark, blocking the light from stars behind them, creating silhouettes against the glowing background of a galaxy. In other regions, they glow softly, illuminated by nearby stars, forming structures that look almost like slow-moving waves or drifting smoke. Millions of years ago, these formations were already present, quietly evolving, changing shape over long periods, influenced by gravity, radiation, and the movement of nearby stars. Inside these clouds, the environment is calm yet full of potential. Temperatures are low, motion is slow, and everything unfolds gradually. Small disturbances, such as the shock wave from a distant supernova, can trigger the collapse of a region within the cloud, starting the formation of new stars. This means that even events that seem distant can influence these quiet regions, connecting different parts of the galaxy in subtle ways. Millions of years ago, this process was happening continuously, linking the life cycles of stars with the formation of new ones. If you could move through one of these clouds, you would not feel anything dramatic. The density is far too low to notice in a direct way. Yet visually, if you could see the gas and dust, you would be surrounded by a faint and soft glow, with areas of deeper shadow and gentle light, creating a peaceful and almost dreamlike environment. These clouds do not rush. They do not change suddenly. They exist in a slow state of transformation, where every small movement takes an immense amount of time. Over millions of years, parts of these clouds collapse into stars, while other parts drift apart, shaped by the energy released from those newly formed stars. Radiation pushes the gas outward, carving out cavities, creating intricate patterns that slowly expand and fade. This constant balance between collapse and expansion gives these regions a dynamic yet calm character, always changing, yet never in a way that feels abrupt. So when we imagine space millions of years ago, we must include these vast and quiet clouds, because they are not empty space. They are the soft foundation of creation, places where the future of the universe slowly takes shape. They connect the life cycles of stars, carry the materials needed for planets, and fill the darkness with a subtle presence that is easy to overlook, yet essential to everything that exists. A gentle reminder that even in the deepest silence of space, there is always something forming, always something waiting to become. As we continue moving through this calm and slowly evolving universe, the quiet clouds of gas and dust begin to reveal what they eventually become. Because within these vast regions, over long periods of time, new stars do not form alone. They are often surrounded by rotating disks of material, and from these disks, entire planetary systems slowly take shape. Millions of years ago, this process was happening in many parts of galaxies, creating new worlds in a gentle and almost invisible way, where nothing happens suddenly, and everything builds step by step over immense stretches of time. When a new star forms, it does not gather all the surrounding material into itself. A portion of the gas and dust remains, spreading into a thin disk that rotates around the young star. This disk is the beginning of a planetary system, and within it, tiny particles begin to stick together, forming larger and larger pieces through countless slow collisions. At first, these are microscopic grains, then small rocks, then larger bodies, and eventually, over millions of years, these growing structures become planets, moons, and other objects. Millions of years ago, many such systems were in these early stages, still forming, still shaping their final structure. The environment within these disks is not chaotic in a fast sense, but it is full of motion. Particles orbit the central star, interacting with each other, sometimes merging, sometimes breaking apart, but overall moving toward growth. Gravity plays a central role, pulling material together, allowing certain regions to gather more mass than others, leading to the formation of larger bodies. In some areas, rocky planets begin to take shape, while in outer regions, where temperatures are lower, gas giants can form, capturing large amounts of surrounding gas. Millions of years ago, many of the planetary systems that exist today were still forming, or had not yet reached their stable configuration. Orbits were not always smooth. Collisions between large bodies were more common, and the structure of these systems was still adjusting. Over time, as material was either gathered into planets or pushed away by radiation and stellar winds, these systems became more stable, with planets settling into consistent paths around their stars. If we consider our own solar system, millions of years ago, it already existed. But even earlier, long before that time, it formed from such a disk around a young sun. The planets we know today were once part of a swirling cloud of material, slowly coming together through this quiet and persistent process. This means that when we look at other stars and see similar disks, we are observing the same process that once created our own planetary home. These forming systems are often surrounded by faint glows of dust, illuminated by their central stars, creating soft and beautiful structures that can be observed from great distances. Millions of years ago, these scenes were common throughout galaxies, quiet regions where future planets were slowly taking shape, long before any possibility of life could emerge. The timescale of this process is important to understand because it reminds us that planets do not appear quickly. They require patience, stability, and a long period of gradual change. Millions of years pass as material gathers, collides, and settles, until a stable system finally emerges. Even after formation, these systems can continue to evolve, with smaller bodies colliding, surfaces changing, and atmospheres forming or disappearing. So when we imagine space millions of years ago, we must include not only stars and galaxies, but also these quiet nurseries of planets, places where entire systems are being built slowly and carefully. They represent the future hidden within the present, regions where the universe prepares what will exist millions or billions of years later. A calm and continuous process that transforms simple dust into complex structures, shaping the cosmos in a way that is both subtle and profound, always moving forward, always creating, yet never rushing. As we continue to move gently through this vast and quiet timeline, we begin to focus more closely on our own galaxy, the Milky Way, a slow rotating system of stars, gas, dust, and unseen matter that has been evolving for billions of years. And millions of years ago, it was already very similar to what it is today. Yet not exactly the same, because even a stable galaxy like ours is always in motion, always changing in subtle ways that only become visible when viewed across long stretches of time. The Milky Way is a spiral galaxy, with long curved arms extending outward from a dense central region, and within these arms stars are born, move, and slowly drift over time. Millions of years ago, these spiral arms were in slightly different positions. Because they are not fixed structures, they behave more like waves moving through the galaxy, guiding the formation of stars as they pass through clouds of gas. This means that regions where stars are forming today were not exactly the same millions of years ago, and areas that were once active may now be quieter. Our position within the Milky Way is also part of this slow motion, because the solar system orbits the center of the galaxy, completing one full rotation in about 200 million years. This means that millions of years ago, we were in a slightly different place along this long journey, surrounded by a different set of nearby stars, seeing a different version of the night sky. The stars that form constellations today were not arranged in the same way back then. Their positions have slowly shifted, creating patterns that are temporary, even if they feel permanent to us. The central region of the Milky Way contains a supermassive black hole, a powerful but distant presence that influences the motion of stars near the core. And millions of years ago, this region may have been more active than it appears now, with gas falling inward and releasing energy. However, from our distant position in the outer parts of the galaxy, this activity would not have been directly visible. It would remain a quiet and hidden influence, shaping the structure of the galaxy without drawing attention. The Milky Way is also surrounded by smaller satellite galaxies, slowly orbiting and sometimes interacting with it. And millions of years ago, these interactions were already shaping the outer regions of our galaxy, pulling streams of stars and gas into new patterns. These processes happen very slowly, over hundreds of millions or even billions of years. Yet they leave subtle traces, faint streams of stars that move together, marking the paths of past interactions. Within the galaxy, star formation continued in many regions, especially along the spiral arms, where clouds of gas are compressed and new stars are born. Millions of years ago, some of the stars we see today had not yet formed, while others that existed back then may no longer be present, having completed their life cycles. This constant renewal gives the galaxy a sense of quiet continuity, where change is always happening, but never feels sudden. If you could observe the Milky Way from millions of years ago from a distant point in space, you would see a familiar shape, a soft spiral of light with glowing arms and a brighter central region. Yet if you looked closely, you would notice differences, slight shifts in brightness, variations in the distribution of stars, and subtle changes in the structure of the arms. It would feel like looking at a living system, one that breathes slowly, expanding and adjusting over time. So the Milky Way from millions of years ago was not a completely different place, but a slightly earlier version of the galaxy we live in now. Already complex, already full of stars in motion, yet still evolving, still changing in ways that are too slow to notice in a single lifetime. It was a calm and balanced environment, shaped by gravity, guided by time, and filled with quiet transformations that continue even now, as the galaxy carries us along its slow and endless path through the universe. As we continue to move quietly backward through time, we begin to approach a moment before something very familiar existed, a time before our own star was born, when the region of space that now holds our solar system was part of a much larger and colder cloud of gas and dust, drifting silently within the Milky Way without any clear center, without any bright source of light nearby, just a diffuse and gentle presence spread across a vast area. Millions of years before the sun formed, this region was not empty. It was filled with the remnants of older stars, material that had been released through supernova explosions and slow stellar winds, mixing together to form a new generation of raw cosmic matter. This cloud, often called a molecular cloud, was extremely cold, with temperatures so low that motion within it was slow and quiet, allowing gravity to act over long periods without disruption. Small variations in density existed within the cloud, tiny differences that would eventually grow into something much larger. But at that time, everything remained balanced, stable, and almost still. Millions of years passed with very little visible change, yet within this stillness, the conditions for something new were slowly forming. The materials inside this cloud were not simple. They already contained heavier elements such as carbon, oxygen, and iron, elements that had been created inside earlier stars and then spread into space. This means that even before the sun existed, the ingredients for planets, atmospheres, and complex chemistry were already present, quietly waiting within this drifting cloud. The universe had already gone through enough cycles of starbirth and death to enrich this region, preparing it for the formation of a more complex system. At some point, something disturbed the calm balance of this cloud. It may have been the shock wave from a nearby supernova, or the gravitational influence of passing stars, but whatever the cause, a region within the cloud began to collapse under its own gravity. This collapse was not sudden, it was slow and controlled, taking millions of years as the material gathered toward a central point, increasing in density and temperature. As this happened, the cloud began to rotate slightly, forming the early structure that would eventually become a star and its surrounding disk. During this stage, the central region grew hotter and denser, while the outer material flattened into a rotating disk And within this disk, the earliest stages of planetary formation began. But before all of that became visible, before the sun ignited and began to shine, this region of space existed in a dim and quiet state, illuminated only by distant stars, surrounded by a soft darkness that carried the potential for future light. If you could observe this region millions of years before the sun was born, you would not see a bright star or orbiting planets. You would see a faint and extended cloud with gentle variations in brightness, slowly shifting over time. There would be no strong light source, no defined structure, just a calm and diffuse presence that hides its future within its quiet form. It would feel like a beginning that has not yet revealed itself, a moment before transformation, where everything exists in possibility rather than in clear shape. This stage reminds us that even the most familiar parts of our universe, including our own sun and planets, began in a state of quiet simplicity, shaped slowly by gravity and time. Millions of years ago, before the sun existed, the space we now call home was already part of a larger story, already connected to the cycles of stars and the movement of galaxies, already carrying within it the materials and conditions needed to create something new. So the universe from that time was not only filled with stars and galaxies, but also with these silent regions of potential, places where future systems were beginning to take form, long before they became visible. It was a universe of quiet preparation, where even in darkness and stillness, the foundations of future light were being gently assembled, guided by forces that move slowly but never stop, shaping what would eventually become the familiar sky we know today. As we continue to drift calmly through this ancient version of the universe, we begin to notice that beneath the quiet and slow movements, there were moments of intense energy, events that released enormous power yet unfolded within the same vast silence of space. And millions of years ago, these cosmic events were sometimes more frequent in certain regions, shaping the evolution of galaxies in subtle but important ways. The universe was not chaotic in a constant sense, but it was not completely calm either. It existed in a balance where long periods of stillness were occasionally interrupted by powerful transformations. One of the most significant of these events is the supernova, the final explosion of a massive star, an event so bright that it can briefly outshine an entire galaxy, releasing energy and material into the surrounding space. Millions of years ago, these explosions were occurring throughout galaxies, especially in regions where large stars had formed and reached the end of their lives. Each supernova sent shockwaves through nearby gas clouds, compressing them, triggering the formation of new stars, and spreading heavy elements that would later become part of planets and other structures. Another type of powerful event comes from the centers of galaxies, where supermassive black holes can become active, pulling in gas and releasing energy in the form of radiation and high-speed jets. During these active periods, the center of a galaxy can shine intensely, influencing the surrounding environment, heating gas and sometimes slowing down the formation of new stars. Millions of years ago, some galaxies experience these active phases more often because they contain more available material to feed their central black holes. There are also gamma-ray bursts, among the most energetic events in the universe, produced during the collapse of massive stars or the merging of compact objects like neutron stars. These bursts release an enormous amount of energy in a very short time, sending narrow beams of radiation across space. Although rare from a human perspective, over millions of years they occur regularly across the universe, contributing to the overall energy environment and occasionally affecting nearby regions in significant ways. Despite the power of these events, the scale of the universe is so vast that most of space remains unaffected at any given moment, allowing large regions to stay calm and undisturbed. This creates a contrast where intense energy exists alongside quiet emptiness, where powerful transformations happen in isolated areas, while the rest of the universe continues its slow and steady evolution. Millions of years ago, this balance was already present, giving the cosmos both its calm appearance and its underlying dynamism. If you could observe the universe from that time, you might occasionally witness a bright flash in a distant galaxy, or detect the subtle influence of an energetic event shaping a cloud of gas. But most of what you would see would still be calm and stable. Stars shining steadily, galaxies drifting slowly, and light traveling patiently across space. The intense events would feel like rare pulses within a much larger and quieter rhythm, moments of change that never fully disrupt the overall peace of the cosmos. These events also play an essential role in the long-term development of the universe, because they redistribute energy and matter, influence the formation of new structures, and help create the conditions necessary for complexity. Without them, the universe would be far less dynamic, far less capable of producing the variety of objects we observe today. Millions of years ago, they were already part of this ongoing process, quietly shaping the future even as they faded quickly into the past. So when we imagine space millions of years ago, we must see it as both calm and powerful, a place where long periods of stillness are gently punctuated by bursts of energy, where creation and destruction exist together in balance. It is this balance that gives the universe its steady flow, a continuous process that unfolds slowly, yet never stops, always moving forward, always changing, even in the deepest silence of space. As we continue to move softly through this ancient version of the universe, the concept of temperature begins to take on a different meaning, because in space, temperature is not felt in the way it is on Earth. It is not warm or cold in a direct sense, but rather a measure of how much energy is present in particles and radiation. And millions of years ago, the overall temperature of the universe was slightly higher than it is today, though this difference is subtle when compared across such immense timescales. The universe has been slowly cooling since its beginning, expanding and stretching, allowing energy to spread out and become less concentrated. In the vast emptiness between galaxies, space is extremely cold, close to what we call absolute zero, a state where particles have very little motion. Yet even this emptiness is not completely without energy. There exists a faint background glow, known as the cosmic microwave background, a remnant from the early universe, filling all of space with a very low level of radiation. Millions of years ago, this background was slightly warmer, not enough to be noticeable without precise instruments, but enough to reflect the continuous cooling of the universe over time. Within galaxies, the situation is more varied. Regions filled with stars are warmer, because stars release enormous amounts of energy in the form of light and heat, affecting the gas and dust around them. Millions of years ago, in areas where star formation was more active, the local environment could be more energetic, with radiation heating nearby clouds, creating differences in temperature from one region to another. In contrast, dense clouds of gas that are shielded from starlight remain extremely cold, allowing gravity to slowly pull them together and begin the process of star formation. Energy in space also moves in the form of radiation, traveling as light across vast distances, carrying information about its source. Millions of years ago, light from stars and galaxies was already filling the universe, moving outward in all directions. Some of it still traveling today, not yet reaching distant regions. This means that the energy released in the past continues to influence the present, slowly spreading and becoming part of the overall background of the cosmos. Another important aspect of energy in space is how it interacts with matter. When radiation encounters gas or dust, it can heat it, ionize it, or push it outward, shaping the structure of clouds and influencing the formation of new stars. Millions of years ago, this interaction was already shaping galaxies, creating regions of activity and regions of calm, depending on how energy was distributed. If you could move through space at that time, you would not feel temperature in the way you expect, but if you had instruments sensitive enough, you would detect differences: warmer regions near stars, colder areas within dense clouds, and the faint, uniform glow that exists everywhere. The universe would feel balanced, not dominated by extreme heat or extreme cold in a constant way, but rather a mixture of both, distributed across different environments. Over millions of years, as the universe continues to expand, these temperatures continue to shift slowly, becoming slightly lower, slightly more spread out, yet always present. This gradual cooling is part of the long-term evolution of the cosmos, a quiet process that does not interrupt the flow of events, but gently changes the conditions under which everything exists. So when we imagine space millions of years ago, we must see it as a place where energy is always present, moving, interacting, and slowly changing, even when everything appears still. The universe at that time was slightly warmer, slightly more energetic in certain regions, yet still calm, still quiet, and still following the same gentle rules that guide it today. A continuous and steady transformation that unfolds across time without ever rushing. As we continue to move quietly through this earlier version of the universe, the way light fills space becomes more noticeable, because everything we see in the cosmos is carried by light. And millions of years ago, the universe was already glowing with the combined light of countless stars and galaxies, spreading gently across vast distances. Light does not remain in one place. It travels constantly, moving through space at a steady speed. And because of this, what we see is always a mixture of different moments in time, some closer to the present, some far in the past. In regions where stars are densely packed, the amount of light can be much greater, creating areas that appear brighter and more active. Millions of years ago, in certain parts of galaxies where star formation was strong, these regions would shine intensely, filled with young stars that emit large amounts of energy. In contrast, other regions would appear softer and dimmer, dominated by older stars that produce a more gentle glow. This balance between brightness and calm light gives each galaxy a unique appearance, one that slowly changes over time as stars are born and fade away. If you could observe the sky from a point within a galaxy millions of years ago, it would feel both familiar and different. The overall presence of stars would remain, yet their exact positions would not match what we see today. Constellations, which appear fixed to us, are temporary patterns formed by the positions of stars relative to our viewpoint. And as stars move over time, these patterns slowly change. Millions of years ago, the night sky would contain different shapes, different alignments, forming constellations that no longer exist in the same way. The brightness of the sky also depends on the surrounding environment. In regions far from dense star clusters, the sky would appear darker, with fewer bright points of light, while in more crowded areas, the sky could be filled with stars, creating a much richer and more luminous view. Millions of years ago, depending on where you were in the universe, the sky could range from almost empty darkness to a dense field of light, reflecting the local structure of stars and galaxies. Light also interacts with gas and dust, creating soft glows in certain regions where clouds are illuminated by nearby stars. These glowing areas, often seen as nebulae, add subtle color and variation to the appearance of space. Millions of years ago, these structures were already present, gently shining, shaped by the radiation of stars and the distribution of matter. In darker regions, where dust blocks light, the sky would contain shadows, areas where distant stars are hidden, creating contrast between light and darkness. Another important aspect of light is how it changes as it travels. Over very large distances, the expansion of the universe stretches the light, shifting it toward longer wavelengths, a process known as redshift. Millions of years ago, this effect was slightly less pronounced than it is today, because the universe was smaller and the distances between galaxies were shorter. This means that the light from distant objects would appear slightly different, carrying subtle information about the state of the universe at that time. If you could observe the universe from millions of years ago with sensitive instruments, you would notice these differences, small variations in brightness, slight shifts in color, and patterns that reflect the positions and movements of galaxies. Yet, to the human eye, the experience would still feel calm and steady, a sky filled with light points, some bright, some faint, all quietly shining, without interruption. So when we imagine space from that time, we must think of it as a place filled with traveling light, a universe where every visible detail is part of a larger story carried across time. The sky would not be completely different, but it would hold subtle changes, patterns that have shifted, stars that have moved, and light that has traveled a little less distance. It would feel like a familiar scene viewed at an earlier moment, a gentle variation of the same vast and peaceful cosmic landscape. Beyond the light that fills the universe, there exists another layer that cannot be seen directly, yet it shapes everything. And millions of years ago, this invisible structure was already guiding the formation and motion of galaxies. This unseen presence is known as dark matter, and although it does not emit or absorb light, its gravitational influence is strong enough to control how matter gathers and moves across cosmic scales. Galaxies are not randomly placed in space. They follow patterns, and these patterns are shaped by vast halos of dark matter that surround them like invisible frameworks. In the ancient universe, these dark matter structures were already well established, forming a kind of cosmic web that stretches across enormous distances. Along this web, galaxies form and cluster together, following paths that are determined by gravity. Millions of years ago, this web was slightly more compact because the universe itself was smaller, meaning that galaxies were closer along these invisible lines. If you could somehow see dark matter, the universe would appear as a network of filaments and nodes, with galaxies sitting along these dense regions, connected like points in a vast structure. Within each galaxy, dark matter forms a halo that extends far beyond the visible stars, holding the galaxy together and influencing how it rotates. Without this invisible mass, galaxies would not behave the way they do. Their outer stars would move differently, and their overall structure would be less stable. Millions of years ago, this influence was already essential, shaping the way galaxies formed and evolved, even though it could not be seen directly. The presence of dark matter also affects how gas moves, how stars form, and how galaxies interact with each other. When galaxies come close, their dark matter halos begin to overlap and interact before the visible parts even touch, creating subtle changes in motion that guide their eventual paths. Millions of years ago, these interactions were part of the slow dance of galaxies, influencing mergers, shaping structures, and contributing to the long-term evolution of the universe. Even though dark matter cannot be observed directly, its effects can be measured through the motion of stars and galaxies. When astronomers study how objects move, they find that there must be more mass present than what can be seen, and this hidden mass is what we call dark matter. Millions of years ago, just like today, this unseen component made up a large portion of the total mass of the universe, quietly dominating its structure without revealing itself through light. If you imagine space from that time, you must picture not only the stars and galaxies that shine, but also this invisible network that holds everything together. It is like a silent framework supporting the visible universe, guiding the flow of matter and shaping the paths that everything follows. Without it, the universe would look very different, less organized, less structured, and far more chaotic. The calm appearance of the cosmos hides this deeper layer of complexity, where unseen forces determine the arrangement of everything we observe. Millions of years ago, this structure was already in place, already influencing the formation of galaxies and the movement of matter, creating a balance between the visible and the invisible. So the universe from that time was not only a place of light and motion, but also a place defined by what cannot be seen. A quiet and powerful presence that shapes everything without ever appearing directly. This adds a deeper sense of stillness to the cosmos, because even the most important forces do not need to be visible to exist. They simply act slowly and steadily, guiding the universe through its endless and peaceful transformation. Far beyond the visible motions of stars and the silent pull of gravity, the universe itself is slowly stretching, expanding in a way that is not immediately noticeable. It yet shapes everything across immense distances, and millions of years ago, this expansion was already happening, gently increasing the space between galaxies, creating a gradual separation that continues even now. This expansion does not feel like movement through space, but rather the expansion of space itself, meaning that galaxies are not simply traveling away from each other. The very fabric between them is growing, slowly and steadily, almost like a surface that stretches without tearing. In that earlier time, galaxies were slightly closer together than they are today, not dramatically so over just millions of years, but enough that their positions relative to one another were subtly different. If you could observe the large-scale structure of the universe from that time, you would notice that galaxy clusters were more compact, their gravitational connections slightly stronger, their interactions slightly more frequent. This closeness allowed more opportunities for galaxies to influence each other, to pass nearby, to slowly distort one another through gravity, and sometimes to begin the long process of merging. This expansion is driven by something even more mysterious than dark matter, a force known as dark energy, which causes the expansion of the universe to accelerate over time. Millions of years ago, this acceleration was already present, but its effects become more noticeable over billions of years, meaning that the universe is not only expanding, but doing so at an increasing rate. However, on the scale of millions of years, the change feels extremely slow, almost impossible to detect without precise measurement, yet it is always there, quietly shaping the future of the cosmos. Light traveling through this expanding universe is also affected. As it moves across space, the stretching of space itself stretches the light, increasing its wavelength, shifting it toward lower energy. This means that the light we receive from distant galaxies carries within it the signature of expansion, a subtle indication that space has grown during the time the light was traveling. Millions of years ago, this effect was slightly less pronounced for any given distance, because the universe was smaller, but the process was already underway, already leaving its imprint on everything we observe. If you could place yourself between distant galaxies millions of years ago, you would not feel this expansion directly. There would be no wind, no force pushing you apart. Everything around you would appear calm and stable. Yet, if you waited long enough, over vast periods of time, you would notice that distant galaxies are slowly drifting away, their light becoming slightly dimmer, their positions gradually changing. This is the quiet nature of cosmic expansion, something that does not disturb the stillness of space, yet continuously transforms its structure. Within galaxies themselves, this expansion does not tear things apart. Gravity holds stars, planets, and gas together, resisting the outward pull of expansion. This means that local structures remain stable, while the space between large systems grows. Millions of years ago, just like today, this balance existed. Galaxies remained intact. Star systems remained stable, while the distances between galaxies slowly increased, creating a universe that becomes more spread out over time. This gradual separation also affects how the universe will appear in the distant future. As galaxies move farther apart, fewer of them will be visible from any single point, and the night sky will slowly become emptier on the largest scales. Millions of years ago, the universe was slightly more connected visually, with galaxies a little closer and easier to observe across distances. This does not change the immediate appearance dramatically, but it contributes to the long-term evolution of how the cosmos looks and feels. So when we imagine space millions of years ago, we must picture a universe that is gently expanding, slowly stretching, creating more room between its vast structures, while still maintaining the calm and steady rhythm of its internal processes. It is a quiet transformation, one that does not interrupt the peace of the cosmos, but gradually reshapes it, allowing everything to drift apart at a pace so slow that it feels almost timeless. A continuous and silent expansion that carries the universe forward into its endless future. Across the immense distances between galaxies, gravity quietly pulls massive systems toward one another, creating encounters that unfold over hundreds of millions of years. And millions of years ago, many of these encounters were already in progress, not as sudden collisions, but as slow and graceful interactions, where galaxies approach, distort, and eventually merge into new forms. These events are among the largest transformations in the universe, yet they happen so gradually that at any single moment they appear calm, almost frozen in time. As two galaxies begin to feel each other's gravity, their outer regions are the first to respond. Stars and gas clouds are gently pulled, creating long streams that extend into space, forming structures that can stretch across hundreds of thousands of light years. Millions of years ago, many galaxies displayed these tidal features, faint and elegant arcs that reveal the presence of an ongoing interaction. These structures do not form instantly. They grow slowly as gravity reshapes the distribution of matter, turning once stable systems into dynamic and evolving forms. During these interactions, stars rarely collide directly, because the distances between them are vast, but their paths change, their orbits shift, and over time the overall structure of each galaxy becomes less ordered. Gas clouds within the galaxies respond more dramatically as they compress and collide, triggering new waves of star formation. Millions of years ago, these bursts of star birth were more common in interacting systems, creating bright regions filled with young, hot stars that illuminate their surroundings. As the interaction continues, the galaxies move closer, passing through each other in a slow and complex motion, their shapes becoming increasingly distorted. Spiral arms stretch and twist. Central regions become more active, and the overall appearance of each galaxy changes significantly. This process can repeat over several passes, each one bringing the galaxies closer together, until eventually they merge into a single larger system. In the final stages of a merger, the original structures are no longer visible. The spiral patterns fade, and the stars settle into new orbits, often forming an elliptical galaxy, smoother in shape with less visible structure. Millions of years ago, many of the large galaxies we see today were still forming through these mergers, gradually building up their mass and changing their appearance through repeated interactions. These events also influence the central regions of galaxies, as gas is funneled toward the core, feeding the supermassive black hole and sometimes triggering periods of intense activity. This can lead to powerful emissions of energy, shaping the surrounding environment and affecting future star formation. Even though these processes involve enormous energy, they remain part of the same slow and continuous flow, never breaking the overall calm of the universe. If you could observe a pair of interacting galaxies millions of years ago, you would see a scene that changes very slowly, delicate streams of stars extending outward, glowing regions where new stars are forming, and two massive systems gradually moving closer together. It would not feel violent, but rather like a slow dance, guided by gravity, unfolding over timescales that are far beyond human perception. These galactic interactions are an essential part of cosmic evolution. They redistribute matter, create new stars, and shape the diversity of galaxies we observe today. Millions of years ago, they were already playing this role, quietly transforming the universe, one interaction at a time. So the universe from that time was not only expanding and drifting, but also gently reshaping itself through these slow encounters where entire galaxies influence one another, merge, and become something new, all within a process that feels calm, steady, and continuous. A silent choreography that unfolds across the vast and peaceful expanse of space. In the deep background of the universe, beyond the visible glow of stars and galaxies, there exists a constant presence of radiation, invisible yet everywhere, filling space with energy that moves silently in all directions. And millions of years ago, this radiation was slightly more intense in certain regions, creating an environment that was more energetic than it might first appear. This radiation does not behave like light from a nearby star. It is often more subtle, spread out, coming from many sources at once, forming a kind of quiet ocean of energy that surrounds everything. One of the main contributors to this background is the radiation left over from ancient events, including the cosmic microwave background, which fills all of space as a faint glow, a remnant from the early universe that has been traveling ever since. Millions of years ago, this background was slightly warmer, slightly more energetic, though still extremely faint, barely noticeable without precise instruments. It acts as a constant reminder that the universe has a history, that even the emptiest regions carry traces of what once happened. In addition to this background, there are cosmic rays, high-energy particles that move through space at nearly the speed of light, originating from supernova explosions, active galactic centers, and other energetic processes. Millions of years ago, these particles were already moving through galaxies, occasionally interacting with gas, dust, and magnetic fields, creating subtle effects that influence the environment over time. These interactions are not dramatic in a visible sense, but they contribute to the overall energy balance of space. Radiation also comes from stars themselves, as they emit light and other forms of energy across a wide range of wavelengths. In regions with many young stars, the amount of radiation can be significantly higher, heating nearby gas and shaping the structure of surrounding clouds. Millions of years ago, in galaxies with active star formation, this radiation played an important role in controlling how and where new stars could form, sometimes triggering formation, and sometimes preventing it by pushing material away. The presence of radiation means that space is never completely inactive. Even in the darkest regions, there is always some level of energy passing through, always some interaction taking place at a microscopic level. Millions of years ago, this quiet activity was already present, creating a subtle layer of motion beneath the calm appearance of the universe. If you could detect this radiation directly, you would not see it as bright flashes or sudden events, but rather as a constant and gentle flow, a background that never disappears, always present, always moving. It would feel like a steady whisper of energy, surrounding everything without drawing attention to itself. Over time, as the universe expands, this radiation becomes more spread out, its energy diluted, its intensity gradually decreasing. Millions of years ago, it was slightly stronger, slightly more concentrated, reflecting the smaller size of the universe at that time. This slow change does not disrupt the overall calm. It simply shifts the conditions under which everything exists, part of the continuous evolution of the cosmos. So when we imagine space from millions of years ago, we must include not only the visible structures, but also this invisible flow of energy, a quiet presence that fills the gaps between stars and galaxies, connecting everything through a constant exchange of radiation. It adds depth to the stillness of space, reminding us that even in silence, even in darkness, there is always motion, always energy, always a gentle activity that never truly stops, shaping the universe in ways that are subtle, yet essential. When we slowly consider the conditions of space millions of years ago, a natural question begins to form: whether the universe at that time was suitable for life in any meaningful way. And the answer is both simple and complex, because while the basic ingredients for life already existed, the environment was often more challenging, more exposed to energetic events, and less stable in many regions. Life as we understand it depends on a delicate balance stable stars, relatively calm surroundings, and planets with the right conditions. And millions of years ago, these conditions were not absent, but they were less common in certain parts of the universe. The elements necessary for life, such as carbon, oxygen, nitrogen, and others, had already been created through the life cycles of stars and spread into space through supernova explosions and stellar winds. This means that by that time, the universe was chemically enriched enough to support the formation of rocky planets and complex molecules. However, the distribution of these elements was still uneven. Some regions were richer, while others remained more simple and less developed. Radiation levels also played an important role, as high-energy events like supernovae and gamma-ray bursts could affect large areas of space, potentially disrupting developing planetary systems or altering the conditions on existing planets. Millions of years ago, in regions with active star formation, such events may have been more frequent, creating environments that were less stable over long periods. This does not mean life was impossible, but it suggests that truly stable and protected regions were more limited. Planetary systems themselves were still evolving in many parts of the universe, with some systems not yet fully formed, and others still experiencing frequent collisions and adjustments. For life to develop, long periods of stability are often required, and millions of years ago, many systems had not yet reached that level of calm. However, in certain areas where stars were stable and planetary orbits had settled, the conditions could already resemble what we consider suitable for life. Another important factor is time, because life does not appear instantly. It requires long periods of chemical evolution and environmental stability. Millions of years, while significant, may not always be enough for complex life to emerge, depending on the starting conditions. This means that even if suitable planets existed, they might still have been in early stages, where simple chemistry was slowly progressing toward more complex forms. If we imagine observing the universe at that time, we would not see life directly, but we would see the conditions that make life possible. Stars providing energy, planets forming and stabilizing, and elements combining in increasingly complex ways. The universe would feel like a place full of potential, not yet fully realized, but steadily moving in that direction. The calm appearance of space hides this gradual preparation, where countless small processes unfold quietly, building the foundations for something more complex. Millions of years ago, the universe was already capable of supporting life in certain regions, but it was still in a stage where many of the necessary conditions were continuing to develop and stabilize. So the universe from that time was not empty of possibility. It was a place where the ingredients of life were present, where the right environments could exist, but where stability and time were still shaping the outcome. It was a quiet preparation phase, where the cosmos was slowly arranging the conditions needed for life to appear, not through sudden change, but through a long and patient process that continues even now, gently guiding the universe toward greater complexity. Far beyond individual galaxies, and even beyond clusters of galaxies, the universe reveals a structure that is vast and almost impossible to fully imagine. A network often described as the cosmic web, where matter is not spread evenly, but arranged along enormous filaments that stretch across space, connecting dense regions like threads in a delicate and silent pattern. Millions of years ago, this structure already existed, guiding the distribution of galaxies and shaping the large-scale appearance of the universe in a way that remains mostly hidden unless viewed from a very distant perspective. This web is formed primarily by the influence of dark matter, which gathers into long filaments and dense nodes, creating a framework upon which visible matter settles. Galaxies form along these filaments, and clusters appear at the intersections where the density is greatest. Millions of years ago, this network was slightly more compact, because the universe itself was smaller, meaning that the distances between these large structures were a bit shorter. and their connections slightly tighter. However, the overall pattern was already in place, already defining the shape of the cosmos. Between these filaments lie vast empty regions known as cosmic voids, areas where very little matter exists and where galaxies are rare. These voids can span hundreds of millions of light years, creating immense spaces of near emptiness that contrast with the dense filaments. Millions of years ago, these voids were also present, though slightly smaller, and the contrast between dense regions and empty spaces was already a defining feature of the universe. This balance between structure and emptiness gives the cosmos its unique large-scale appearance, a combination of connection and separation that unfolds across unimaginable distances. If you could observe the universe from a perspective far outside any galaxy, you would not see a random scattering of light, but a complex network, glowing where galaxies cluster, fading where voids expand, forming patterns that resemble a living structure, slow and stable, yet constantly evolving. Millions of years ago, this view would be similar, though slightly more condensed, with galaxies appearing a bit closer along the filaments and clusters showing stronger gravitational ties. This structure does not change quickly. Its evolution happens over billions of years. Yet even across millions of years, small shifts occur. Filaments stretch slightly, clusters grow as galaxies fall into them, and voids expand as matter moves away. These changes are subtle, almost impossible to detect in short time spans. But they are always happening, always reshaping the cosmic web in a quiet and continuous way. Within this network, the motion of galaxies is not random. They follow the paths defined by gravity, moving along filaments toward denser regions, slowly gathering into clusters. Millions of years ago, galaxies were already following these paths, contributing to the gradual growth of large structures. This movement is slow and steady, guided by forces that act over immense distances, creating a sense of order within the vastness of space. The cosmic web also influences the flow of gas, which moves along the same filaments, feeding galaxies and supporting star formation. This means that even the smallest processes, like the birth of stars, are connected to the largest structures in the universe. Millions of years ago, this connection was already active, linking the smallest scales to the largest in a seamless and continuous system. So when we imagine space millions of years ago, we must expand our view beyond individual objects and consider the entire structure of the universe, a vast and interconnected network that stretches across all directions. It is a quiet architecture, invisible at small scales, yet dominant when seen as a whole, shaping the distribution of matter, guiding the motion of galaxies, and defining the overall form of the cosmos. This structure adds a deeper level of calm to the universe, because it shows that even at the largest scales, everything follows a pattern. Everything is connected, and everything moves slowly within a grand and peaceful design that continues to evolve without ever losing its balance. Within the vast structure of galaxies, there are smaller communities of stars that move together through space, forming what we call star clusters. And millions of years ago, these clusters played an important role in shaping the appearance and evolution of galaxies, creating regions where stars were more densely packed, more closely connected, and often born at the same time. These clusters are not permanent. They slowly change, spread, and sometimes dissolve. But during their existence, they create a unique environment where stars share a common origin and a similar journey through space. There are two main types of star clusters: open clusters and globular clusters, each with its own characteristics and history. Open clusters are relatively young, loosely bound groups of stars that formed from the same cloud of gas. And millions of years ago, many of these clusters were still bright and well-defined, with their stars remaining close together, moving in similar directions. Over time, gravitational interactions with other stars and structures cause these clusters to slowly disperse, spreading their stars into the surrounding galaxy. This means that millions of years ago, Some clusters that no longer exist as clear groups today were still intact, still shining as recognizable collections of stars. Globular clusters, on the other hand, are much older and more tightly bound, containing hundreds of thousands of stars packed into a spherical shape. These clusters orbit the outer regions of galaxies, moving slowly and maintaining their structure over extremely long periods. Millions of years ago, these globular clusters were already present, already ancient, and already following their long paths around the galaxy. Their appearance would not change dramatically over such a timescale, but their positions would shift slightly, contributing to the overall motion of the galaxy. The presence of these clusters affects the way the sky would appear from within a galaxy. In regions near open clusters, the sky could be filled with bright stars, many more than what we see from Earth, creating a dense and luminous view. Millions of years ago, depending on the position of a planetary system, the night sky could have been richer in stars, with clusters appearing as concentrated groups of light. In other regions, far from such clusters, the sky would remain more sparse, with stars more evenly distributed. Clusters also play a role in the evolution of stars, because their shared origin means that astronomers can study them to understand how stars change over time. Millions of years ago, clusters contained stars at similar stages of development, allowing patterns to form, some stars brighter and larger, others smaller and dimmer, all evolving together in a slow and predictable way. This makes clusters like natural laboratories, where the life cycle of stars can be observed more clearly. Over time, the gravitational interactions within a cluster and with the surrounding galaxy cause gradual changes. Stars may be pulled away, the cluster may stretch or lose its shape, and eventually it may fade into the background of the galaxy. Millions of years ago, many clusters were at earlier stages of this process, more compact, more clearly defined, and more visually distinct than they might be today. If you could observe the sky from that time, you might notice these clusters as bright gatherings of stars, standing out against the darker background, creating patterns that feel more concentrated and more vivid. These patterns would slowly change as stars move, but over a short time, they would appear stable, adding to the calm and steady appearance of the cosmos. So the universe from millions of years ago included not only individual stars and vast galaxies, but also these smaller communities, where stars were born together and traveled together for a time. They add another layer to the structure of space, showing that even within the immense scale of the universe, there are regions of closeness and shared origin, places where stars form connections, before gradually drifting apart, continuing the slow and endless movement that defines the cosmos. If we gently shift our perspective and look at the universe not as a fixed place, but as something that ages, it begins to feel almost like a living system, one that had a more active and energetic past. And millions of years ago, we were still within a phase where many regions of the universe were slightly more dynamic than they appear today. This does not mean constant chaos, but rather a subtle increase in activity, where star formation, energetic events, and interactions between structures were a bit more frequent, creating a cosmos that was quietly more vibrant beneath its calm surface. In many galaxies, especially those rich in gas, the formation of new stars was happening at a higher rate because there was still plenty of raw material available to fuel the process. Massive clouds of gas had not yet been fully consumed, and this allowed new stars to form more easily in certain regions. Millions of years ago, these areas would appear brighter and more active, filled with young stars that emit strong light and energy, giving parts of galaxies a more luminous and lively appearance. This increased activity also meant that the life cycles of stars were progressing in a slightly more noticeable way, with more massive stars reaching the end of their lives and producing supernova explosions. These events contributed to the enrichment of the surrounding space, spreading heavier elements and influencing the next generation of star formation, even though these explosions are rare on human timescales. Over millions of years, they occur often enough to shape entire regions of a galaxy. Galactic interactions were also somewhat more common in certain areas, as galaxies were slightly closer together, increasing the chances of gravitational encounters. These interactions do not happen quickly, but their early stages would have been more visible, with galaxies beginning to distort, forming tidal streams, and slowly altering their shapes. Millions of years ago, some galaxies were already in the early phases of these long interactions, setting the stage for future mergers. At the same time, the central regions of some galaxies were more active, as their supermassive black holes consumed surrounding material and released energy. This activity could influence the formation of stars by heating nearby gas or pushing it away, creating a balance between creation and suppression. Millions of years ago, this balance was still shifting in many galaxies, contributing to their gradual evolution. Despite this increased level of activity, the overall feeling of the universe would still be calm, because all of these processes unfold slowly, without sudden changes that can be easily perceived. The difference lies in the frequency and distribution of events, not in their intensity at any single moment. The universe was quietly more active, yet still deeply peaceful, maintaining its steady rhythm across time. If you could observe a galaxy from that period, you might notice slightly more bright regions, slightly more variation in light, and subtle signs of ongoing change, but nothing that disrupts the overall sense of stillness. Everything would continue to move in slow motion, guided by gravity and energy, creating a continuous flow that never truly stops. So the universe from millions of years ago can be understood as being in a slightly more youthful phase, not dramatically different, but gently more active, with processes unfolding a bit more frequently, contributing to the gradual shaping of the cosmos. It is a reminder that even in its calmest appearance, the universe is always evolving, always moving forward, always adjusting its structure in quiet and persistent ways that only become clear when we look across vast spans of time. Even though space is often described as completely silent, when we think more carefully about what exists there, it becomes clear that the universe is not truly empty of activity. It is filled with motion, energy, and constant interaction, just without sound as we understand it, because sound requires a medium like air or water to travel, and in the vacuum of space there is no such medium. Yet millions of years ago, just like today, the universe was full of what could be described as a different kind of noise, a silent complexity where particles, radiation, and gravitational waves move endlessly through the cosmos. This quiet activity includes the motion of particles traveling at high speeds, cosmic rays passing through regions of space, and light waves crossing unimaginable distances without interruption. None of this produces sound in the traditional sense, but if it could somehow be translated into a form we could perceive, it would not be silent. It would be a continuous and subtle flow of information and energy. Millions of years ago, this invisible motion was already present everywhere, creating a background of activity beneath the calm appearance of space. Gravitational waves add another layer to this hidden movement. These are ripples in the fabric of space itself, created by massive events such as the merging of black holes or neutron stars. They travel outward across the universe, stretching and compressing space as they pass, yet they do so without sound, without light, and without any direct sensation, unless measured with precise instruments. Millions of years ago, these waves were already moving through space, carrying the signatures of distant and powerful events across vast distances. Within galaxies, stars orbit their centers. Gas clouds drift and collapse, and clusters of stars move together. All of this creating a constant state of motion that, while silent, is never still. If there were a way to convert these movements into sound, the universe would feel alive with a deep and steady rhythm, not chaotic or loud, but continuous, and layered, a kind of slow and endless composition. Even the smallest scales are not truly still. Atoms vibrate, particles interact, and energy shifts from one form to another, all without producing sound, yet contributing to the overall activity of the cosmos. Millions of years ago, this microscopic motion was just as present, forming the foundation of everything that exists on larger scales. If you could exist in space with the ability to perceive these hidden movements, you might experience something very different from silence, a sense of constant presence, where energy flows around you, where distant events send faint signals through space, and where nothing is ever completely at rest. Yet without that perception, space feels calm, still, and peaceful, creating the illusion of total quiet. This contrast between apparent silence and underlying activity is one of the defining features of the universe. It allows space to feel restful and undisturbed, even while countless processes are taking place at every moment. Millions of years ago, this balance already existed, giving the cosmos its unique character, a place where motion and stillness coexist without conflict. So when we imagine space from that time, we can think of it as a silent landscape filled with invisible motion, where everything is happening slowly and continuously, yet nothing breaks the calm. It is a quiet complexity, a hidden rhythm that moves through the universe without ever becoming noise, creating a sense of deep peace that remains unchanged across millions of years. Every direction you look into space is not only a direction in distance, but also a direction in time. Because light does not arrive instantly, it travels patiently, carrying with it the exact state of the universe from the moment it was emitted. And millions of years ago, this process was already filling space with information, creating a continuous stream of messages moving silently across the cosmos. This means that the universe is not only what exists now, but also what has existed, preserved in the light that is still traveling. When a star shines, the light it produces begins a journey that can last for years, thousands of years, or even millions of years depending on the distance. Millions of years ago, countless stars and galaxies were sending out light that has not yet reached certain parts of the universe, and some of that light is still arriving today, revealing what those distant places looked like in the past. This creates a unique situation where observing space is also observing history, where distance and time become connected in a quiet and precise way. If you could place yourself far away from our galaxy and look toward it, you would not see it as it is now. You would see it as it was when the light left it, which could be millions of years ago. This means that different observers in different locations would see different versions of the same object, depending on how far away they are. Millions of years ago, this principle was already true. Light from distant regions was already on its way, carrying information that would only be revealed much later. This also means that when we ask what space was like millions of years ago, we do not need to imagine entirely, because in many cases we can observe it directly by looking far enough away. Distant galaxies show us earlier stages of the universe, where structures are younger, interactions are more common, and the overall appearance can be slightly different. This is not a reconstruction. It is a direct observation made possible by the finite speed of light. Light also changes as it travels, affected by the expansion of the universe, stretching over time and shifting its properties. Millions of years ago, the light traveling through space had experienced less stretching compared to what we observe over billions of years. But the process was already active, already shaping the signals that move across the cosmos. This adds another layer of information, allowing us to understand not only where light came from, but also how space itself has changed during its journey. If you could stand in space and observe the incoming light from all directions, you would be surrounded by a continuous flow of images from different times, some recent, some ancient, all arriving together. It would feel like being inside a moving archive, where the past is constantly being delivered, never fully disappearing, always present in some form. Millions of years ago, This flow was already in motion, already carrying the history of the universe forward. This makes the universe feel less like a fixed moment and more like a layered experience, where every point in space contains traces of different times, overlapping and blending into a single view. The calm appearance of the night sky hides this complexity, presenting a simple image that is actually composed of many different moments, each one traveling through space to reach us. So when we imagine space from millions of years ago, we can understand that it is not completely separate from the present. It is still visible, still arriving, still part of what we see. The universe does not lose its past. It carries it forward through light, allowing it to remain accessible, a quiet and continuous record that moves through the cosmos without ever stopping, connecting every moment across time in a calm and seamless way. Long before human history, and even before the earliest life on Earth, our planet and its star were already moving through the Milky Way, following a slow and steady path around its center. And millions of years ago, this journey was already shaping the environment around us in subtle ways. The solar system does not remain fixed in one place. It travels through different regions of the galaxy, sometimes passing through areas with more gas and dust, sometimes moving through clearer and quieter space. And these changes affect the surroundings in gentle but meaningful ways. Millions of years ago, the solar system was located in a slightly different position along its orbit, meaning that the nearby stars, the density of interstellar material, and the overall environment were not exactly the same as they are today. This does not mean a dramatic difference, but rather a gradual shift where the local neighborhood of space changes over time. Stars that are close to us now may have been farther away then, and others that were once nearby may have moved on, creating a constantly evolving stellar environment. The motion of the solar system also causes changes in the appearance of the night sky, as the relative positions of stars slowly shift. Millions of years ago, the constellations that we recognize today did not have the same shapes, because stars move independently through space, each following its own path. Over long periods, these small movements accumulate, creating entirely different patterns. A sky that would feel unfamiliar, yet still filled with the same quiet points of light. As the solar system travels, it may also encounter regions of denser gas and dust, which can influence the flow of cosmic particles reaching the planets. Millions of years ago, passing through such regions could have slightly altered the radiation environment. Though these changes are usually subtle and unfold over long periods, the galaxy is not uniform. It contains areas of varying density, and moving through them creates a slow variation in the conditions surrounding a planetary system. The gravitational influence of nearby stars can also change over time, though usually in small ways. As stars pass relatively close, they can slightly disturb distant objects in the outer parts of a system, such as comets in a distant cloud surrounding the solar system. Millions of years ago, these distant interactions may have been shaping the outer regions, sending occasional objects inward, contributing to a slow and ongoing exchange between the solar system and the wider galaxy. If you could observe the solar system from a distant point millions of years ago, you would see it as a small and stable system, orbiting quietly around the galactic center, surrounded by a different arrangement of nearby stars. The overall structure would be familiar. Planets moving in steady paths, the stars shining consistently, yet the background would be different. A new pattern of stars forming the surrounding sky. This constant motion reminds us that even though space feels vast and unchanging, everything is in motion. Everything is slowly shifting position over time. Millions of years ago, our place in the galaxy was not fixed. It was part of a continuous journey, one that began long before and will continue far into the future. So when we imagine space from that time, we must include not only distant galaxies and cosmic structures, but also our own movement within the galaxy, a quiet travel through changing surroundings. Where the local environment evolves, the sky transforms, and the connection between our system and the wider universe continues to unfold in a calm and steady way, always moving, always changing, yet always maintaining a sense of deep and peaceful continuity. If you could somehow observe space millions of years ago, with eyes capable of seeing every wavelength of light, the universe would not appear empty or colorless. It would reveal a rich and layered texture, filled with subtle hues created by gas, dust, and radiation, forming a visual environment that is both calm and complex. Colors in space are not like colors on Earth. They are often faint, stretched, and shaped by the interaction between light and matter. And millions of years ago, these colors were already present, quietly defining the appearance of nebulae, galaxies, and the spaces between them. Different elements emit and absorb light in different ways, creating distinct colors when they are energized by nearby stars. Hydrogen, the most abundant element, often produces a soft red glow, while oxygen can create bluish and greenish tones, and other elements add their own subtle variations. Millions of years ago, these processes were already active, meaning that regions of space filled with gas would display gentle color gradients, shifting slowly as conditions change. These colors are not bright in the way artificial lights are bright. They are soft and diffuse, blending into the darkness rather than overpowering it. Dust plays an important role in shaping how these colors appear, as it scatters shorter wavelengths of light more effectively, creating faint blue reflections around bright stars, while also blocking and absorbing light in other regions, producing darker areas that contrast with the glowing surroundings. Millions of years ago, this interaction between dust and light was already giving space a layered appearance, with glowing regions, shadowed areas, and soft transitions between them. Within galaxies, the distribution of colors can reveal different stages of stellar evolution. Regions with young stars often appear bluer due to their higher temperatures, while older regions tend to glow with warmer, redder tones. Millions of years ago, galaxies contained these same variations, though the exact patterns would differ depending on where star formation was most active at that time. This creates a dynamic visual texture where color is not fixed, but constantly evolving as stars are born and age. If you could move through a nebula millions of years ago, you would not see sharp edges or solid forms, but rather soft clouds with gradual changes in brightness and color. A gentle blending of light and shadow that feels almost fluid. The boundaries between different regions would not be clear. They would fade into each other, creating a sense of depth and calm that is difficult to fully capture in a single image. On larger scales, the colors of galaxies themselves would appear as soft combinations of light, with brighter centers, dimmer outer regions, and occasional patches of more intense color where star formation is taking place. Millions of years ago, these galaxies would look similar in structure, yet slightly different in detail, with variations in brightness and color that reflect their ongoing evolution. Even the darkness of space is not completely empty. It provides contrast, allowing the faint colors to stand out, creating a balance between light and absence. This balance gives the universe its visual calm, where nothing feels overwhelming, and everything blends into a continuous and peaceful scene. So when we imagine space millions of years ago, we can think of it not as a black void, but as a subtle and softly colored environment where light interacts with matter to create gentle variations in appearance, where every region carries its own faint signature, and where the overall view is one of quiet beauty. It is a universe painted with delicate tones, always changing, yet always maintaining a calm and harmonious presence across the vastness of space. If you pause and imagine watching the universe not for seconds or years, but for millions of years, you would begin to notice that everything changes, yet nothing feels sudden, because cosmic change happens at a pace so slow that it blends into stillness. Stars shift their positions, Galaxies drift apart, clusters evolve, and structures stretch. But each movement is so gradual that at any single moment, the universe appears calm and unchanging. Millions of years ago, this same slow transformation was already in progress, shaping the cosmos in ways that only become clear across vast stretches of time. Every object in space follows a path. Stars orbit within galaxies, galaxies move within clusters, and clusters themselves follow the deeper structure of the cosmic web. These motions never stop, but they are so gentle that they create the illusion of permanence. Millions of years ago, stars in the sky would have been in slightly different positions. Yet, to any observer living in that time, the sky would appear stable, almost fixed, because the changes would be too small to notice within a lifetime. This slow movement also affects the internal structure of galaxies. Spiral arms shift, regions of star formation appear and fade, and clouds of gas move and collapse over long periods. Millions of years ago, these processes were already shaping galaxies, creating patterns that evolve gradually without any clear beginning or end. A bright region today may have been dimmer then, and a quiet area may have been more active, but the overall form remains recognizable, a steady balance between change and continuity. Even the largest structures, such as galaxy clusters and cosmic filaments, are not fixed. They slowly stretch and adjust as the universe expands. Millions of years ago, these structures were slightly more compact, their connections slightly tighter, yet the difference would not be dramatic from one moment to the next. Only by comparing distant points in time can the full extent of this transformation be understood. On smaller scales, stars themselves change, though often slowly. Their brightness can vary. Their size can increase or decrease, and their energy output can shift over time. Millions of years ago, some stars that are stable today were slightly different, and others that existed then may no longer be present. Yet the overall population of stars remains balanced, new ones forming as old ones fade away, maintaining a steady presence across the galaxy. This continuous change creates a universe that is always evolving, yet always calm, a place where motion never stops, but never becomes chaotic. Millions of years ago, the same quiet transformation was taking place, guiding the cosmos forward without any sudden disruptions. If you could observe the universe across millions of years in a single moment, you would see a slow and graceful flow, galaxies moving like distant currents, stars tracing long arcs through space, and structures expanding gently outward. It would feel less like a series of events and more like a continuous motion, a steady unfolding that never pauses. So when we imagine space from that time, we must understand that it was not static. Even if it appeared that way, it was already changing, already evolving, already moving toward its future. The calmness of the universe does not come from stillness, but from the smoothness of its change. A quiet progression that carries everything forward at a pace so slow that it feels timeless, a constant transformation hidden beneath a peaceful and unbroken surface. When we gently bring together everything we have explored, a clear picture begins to form. The universe from millions of years ago was not a completely different place, but a slightly earlier version of the same vast and continuous system, already filled with galaxies, stars, clouds of gas, and invisible structures guiding everything in quiet balance. The differences between that time and now are real, but they are subtle, spread across immense scales, shaped by slow processes that unfold without urgency. Galaxies were a little closer to each other, their interactions slightly more frequent, their structures still adjusting through gravity and motion. Stars were at different stages of their lives. Some that shine today did not yet exist, and some that once shone have already faded. Clusters of stars were more compact in certain regions, and patterns in the sky would have looked different, unfamiliar, yet still calm and filled with light. These are changes that do not disrupt the overall appearance, but gently reshape the details. The universe itself was slightly denser, slightly warmer in its background energy, and the radiation filling space was a bit more concentrated. Cosmic events such as supernovae, energetic bursts, and active galactic centers were part of the same ongoing rhythm, quietly influencing their surroundings without breaking the overall stillness. The cosmic web, the vast structure connecting everything, was already present, slightly tighter, slightly more connected, guiding the motion of galaxies across immense distances. In our own region of space, the solar system was in a different position along its long orbit around the galaxy, surrounded by a different arrangement of nearby stars, under a sky that would not match the constellations we recognize today. Yet the same processes were in motion, stars forming, planets evolving, and the galaxy continuing its slow rotation. The sense of continuity remains, even as the details shift over time. The most important realization is that the universe does not change in sudden steps. It flows. Everything transitions gradually. Everything evolves through small differences that accumulate across millions and billions of years. Millions of years ago, the universe was already stable, already structured, already following the same fundamental patterns that we observe now. It was not younger in a way that feels incomplete, but younger in a way that feels gently in progress. If you could move between that time and the present, you would not experience a shock. You would notice differences slowly, patterns that do not quite match, distances that feel slightly altered, arrangements that are subtly shifted. It would feel like watching the same landscape at different moments, where the overall form remains, but the details continue to change. This continuity gives the universe its calm and steady nature, a sense that everything belongs to a single, unbroken story. Millions of years ago, that story was already unfolding, just as it is now, guided by the same forces, following the same paths, moving forward without interruption. So when we imagine space from that time, we are not looking into a distant and unfamiliar reality. We are looking into an earlier moment of the same universe we exist in, a quiet and vast place where change is constant but gentle, where time stretches endlessly, and where everything continues its slow and peaceful journey through the infinite darkness, always evolving, always connected, and always at rest within its own motion.